Hello everyone, welcome back to my channel. In today's video I will tell you about object-oriented programming in the simplest language with the clear examples. Examples and concepts that I will talk about during this video do not depend on a specific programming language and will be useful both for developers working with the Python as well as Java and the C-like languages. I will show all examples in a Python, but as I say, they will be understood to developers from various programming background. Let's go through all the main concepts such as classes, objects, and the three pillars of the object-oriented programming, which are encapsulation, inheritance, and polymorphism. But before we go, I want to say your engagement and feedback mean a lot to me. If I see active discussion and interest in this video, I'll be thrilled to create more content on this topic. In fact, I'm already excited to share that one of the next video will be about the solid principles. So if you're interested, click a like and leave a comments. So let's start. Before studying object-oriented approach to the programming, let's take a look at the procedural approach, from which everyone usually begins to study programming. The program is written in the procedural styles, waits for some data to enter, performs a number of some procedures, they are also called the functions, and after that returns some kind of a results, the results of calculations. Let's take a look at the example. There is a function, calculate area, which accepts width and height as argument, and as a result return multiplying width by height, that is the area of a rectangle. As a result of passing some data to our function, we get the area of a rectangle. Such approach are called procedural. Initially, all programs were written with the procedural approach, but when the programs became large, many lines, a lot of code, it became clear that this approach was not suitable. It is difficult to configure the application, it is difficult to manage some entities, it is difficult to make decomposition. And when procedural programming became insufficient, an object-oriented approach was invented, which was perceived by the community of programmers as a powerful solution capable of solving all problems. The object-oriented approach revolves around two main concepts: classes and objects. A class defines blueprint that encapsulate data, properties, and behavior methods of objects. An object, on the other hand, is an instance of a class with specific values for its properties. Let's look at two main concepts of object-oriented programming. There is a person, and the person, let's say, can be characterized by the following properties. This is name, surname, age, weight, and height. This is a list of characteristics with which any person can be characterized. At the same time, in the concept of OOP, such a characteristic is called a class. There is a class of a person. A specific class representative, an example, is called an object. In this example, this is Joe Jones, who is 26 years old. Repeat again, a class is some description of a characteristic. An object is a specific example, each of which has some kind of meaning. For example, the name is John. In the context of OOP, the characteristics name, surname, and so on are called properties, and the actions that an object can perform are called methods. For example, work, eat, sleep. Let's take a look at the example right away. There is a class, a rectangle. It has two properties. This is width and height respectively. There is also one unique method with which you can calculate the area of the rectangle. By self, in this case, implies an object that will call this method. Also, any class has constructor. This is a special method, some block of instruction that is called when creating an object. It can also take some arguments. Usually in the constructor, the properties of the object are assigned some values. In this case, we take height and width of the rectangle and save them. We can create an object. The object, as I said, is a separate copy of any class. At the same time, we pass the arguments width of the rectangle equal to 5 and height equal to 10. From the created object, we can call the corresponding method that will return us the area of the object. At the same time, we can create as many copies of the class as we want. Let's run. As you can see, we have two copies of our class and they return the values of area. In this example, each of the rectangles has a different width and height. Each class can include as many properties and methods as it takes, but a good practice is to make classes for specific tasks. OOP is built on the three main concepts. There's encapsulation, inheritance, and polymorphism. Let's briefly talk about each and start with encapsulation. Here we have a class of a person who has his own properties and methods. The concept of encapsulation is very closely intersect with such a concept as concealment. And let's figure out what is what. Encapsulation is actually a very simple concept that is often very much like to complicate. Its essence is that the class itself is a kind of capsule that contains properties and methods for working with these properties. It allows them to be united. This seems to be a very obvious property, but if you look at this property from the context of a procedural programming where are no such capsules, then everything immediately becomes in its place, and the principle of encapsulation becomes clear. But as I said, there is always concealment next to encapsulation, and here is a little more difficult to explain, so let's look at the example. Each person has a name, surname, age, and in fact this is a public data. They are not secret to anyone, we can work with them calmly. The same applies to the methods. A person can walk, write, code, draw, speak. And if you look at this from the code side, the developer who wrote the class foresaw that from anywhere he's attached, when a person uses the class, he will always be able to address these properties and these methods. And at the same time, the logic of the program does not break down. But besides everything, there is also a closed part. What we cannot work with, what we cannot influence. For example, how the heart pumps the blood, how the body digests food, process information. This, roughly speaking, is a hidden part that inside person himself and on which we cannot influence from the outside. In order to make some methods and properties public or private, there are so-called access modifiers. In Python, it's done by underscores. It's actually a two type, it's protected and private, but now we will talk only about the private. It is two underscores. The properties and methods that are marked with a private modifier can only be used inside the class. It is impossible to call them from the outside. If you come up with the example closer to the writing the code, then let's say we have some class database, and this class has a property of a URL for connecting to the database and the port. At the same time, the developer who writes this class understood that if someone decides to change the URL, then the connection to the database will fail and the class will stop working. For this very reason, we make this property private, and the only way to set the value of the URL and the port is the class constructor. That is, we set the parameters once we create the object and forget about them. Let's move on the example. In the example, we have a bank account class with a private property balance. The deposit and withdraw methods allow us to add and subtract funds from the account, respectively. But they also include checks to ensure that valid transactions are performed. Accessing the balance property directly from the outside the class will raise an attribute error. Instead, we can use the getBalance method to access the balance in a controlled manner. And here we have our balance. This demonstrates encapsulation as we have a hidden internal representation of the balance and provide specific methods, deposit and withdraw, to interact with it. I hope this example were enough. We have considered encapsulation, moving on. We move on to inheritance. Inheritance is also extremely easy. And again, let's look at the example. We have a class a person, which has a name, surname, age. At this stage, we don't need any other data. We also have a class worker. It also has a name, surname, and age, but in addition to all this, there are data that are needed for employee, such as ID, passport number, form W4, and so on. It turns out that the class worker inherits properties and methods from the class person. In a different way, we can say that the class worker expands the class person. Moving along the chain further, we have the class developer. In addition to the name, surname, and everything that the worker does have, the developer has its own properties that are needed for specifically for it. For example, the programming language with which this developer works, the command number, and other properties. A well-designed OOP systems allow you to reuse the code very effectively, scale it, and maintain it. And a very important screw in this system is just the inheritance mechanism. We have discussed the theory, now let's move on the practice and see how to implement it. Imagine we are building a program to represent various animals. To keep things organized, we'll create a base class called animal that captures common attributes and behaviors shared by all animals. Here we have an abstract class animal. We use the name and species attributes to encapsulate the animal's names and species. We pass these variables to the constructor of the class, and also we have separate methods for make a sound, eat, and sleep. Now let's create a specific animal classes that inherit from the animals base class. And we have two derived classes, dogs and cat. They inherit from the animal base class and add specific attributes and methods that are unique to each type of animal. So as you can see, in class we extend the method make sound and make it print woof for the dog and print meow for the cat. Also we add some method to the dog class, fetch the ball, and for cat it's purr. Now let's use the animal class and see how inherit allows us to access both base and derived class methods. As you can see, we can access make sound, eat, and sleep methods defined in the animal base class through the derived class. Additionally, each derived class has its own unique methods like fetch the ball for dog and purr for cat. Now let's enhance our animal classes by incorporating encapsulation with the getters and setters. We add getName and setName methods to provide controlled access to the name attribute. Let's use encapsulation to access the modified animal's name. So here, as you can see, we print the new name for Whisker. Into conclusion, inheritance allows us to create a hierarchy of the class, enabling the code reuse and providing a clear structure. Coupled with encapsulation, it promotes data protection and control access to the class attributes. And we move on to the third concept, polymorphism. I highlight two main types of polymorphism. This is parametric polymorphism and so-called ad hoc polymorphism. Moreover, the second is the imaginary and the first is the truth. Before moving on the review of these types, first let's consider what polymorphism is and give it definition. If you enter the name polymorph, it becomes clear that it is something multi-faced. In fact, the poly it's many and morph it's a form. So it's mean the many forms. In the context of OOP, polymorphism can be perceived as some kind of principle that allows the same fragment of the code to work with the different types of data. This is a very important principle, probably the one of the most important principle of OOP, and is based on the overwhelming number of patterns in the design principle. But all principles of OOP are connected, and without the same inheritance, polymorphism would not be possible. Before starting to review the most interesting type of polymorphism, namely parametric, we will consider ad hoc to immediately cut it off. Ad hoc polymorphism, also known as a function overloading, allows a function or method to have a different implementation based on the number or types of arguments provided. In Python, we can achieve ad hoc polymorphism using default arguments. It's important to know that Python does not natively support traditional function overloading like some other languages such as Java. Instead, Python determines the implementation of a function based on the number of arguments provided. Here is an example of ad hoc polymorphism using default arguments. In this example, greet function has two parameters, name and greeting. The greeting parameter has a default value of hello, If a greeting argument is not provided, when calling the function, it will use the default value. Let's run and see. So here, as you can see, we have hello Alice, the default parameter, and in the second example, we call it with a hi, and here we have a hi Bob. So with the default value, we override the parameter of a greeting. Parametric polymorphism, also known as generic programming, allows a function or a data type to work with a range of types without being tied to any specific type. This is typically achieved using generic type parameters in programming languages that support it. In Python, we can demonstrate parametric polymorphism using the function or class generics with the help of type hints. Here is an example of parametric polymorphism using generic function. In this example, we define a function, print element, that takes a list of elements of generic type t and label as input. Generic type t allows this function to work with a list of different types, such as integers, strings, or tuples. Now let's run and see the result. As you can see, we print the different type of values, but we have only one function that intake these lists. Now I want to show you the more complex example. Here we have implementation of a stack, and with the type var t allow us to create a generic type that can represent any data type. So here we have two methods, push and pop, and as you can see in this example, we push integers and words. It should work correctly. So let's run. And as you can see, we output integer and output word as expected. In conclusion, polymorphism is a crucial concept in object-oriented programming that allows for the creation of flexible, reusable, and adaptable code. It enables a single interface or function to be applied to different data types or objects. Polymorphism allows us to write a more generic and reusable code that can work with the different types without duplicating the implementation. And that's all for today. I tried to tell you in as shortest time as possible, in as simplest word about the object-oriented programming and about all its main principles. I tried to pick up examples as close as possible to reality and at the same time to make them understandable. If you have not been familiar with OOP before, you probably have a lot of questions now. I recommend watching this video again, more concisely. Well, in general, I will ask you to give a feedback, write what you like, what you did not like, what was clear, what was not clear, what should I improve. I always listen to you and read the comments. And of course, don't forget to like so that my work is not in vain. Write a comment, support and subscribe, and I will be waiting for you in the next videos.